Welcome to lecture 19, which is on multi-concept in remote sensing. In this lecture, I am going to cover what are the different aspects which are covered under multi-concept and how they are useful when we want to select a particular data or we want to carry out the analysis from multiple data sets. So, let us begin the lecture. In multi-concept in remote sensing is very useful, and it is the key concept when we are acquiring right from the acquisition of the satellite data to the selection of the satellite data and its analysis part. So, this is playing very important role. So, we are here talking about a multi-stage. It is taken from the different heights. We are talking about the multi-resolution, as you have seen in the earlier lecture also, that the different satellites, different sensors are giving us the different resolution satellite data, multi-spectral bands. Each satellite sensor is working in more than one spectral bands. Then we have multi-detectors, several sensors. One satellite will have more than one sensors. Multi-temporal data, how the different data from different satellites are useful to us, and what are those multi-uses, how one satellite data could be used for multiple applications. So, this is all called multi-concept in remote sensing, and this is a very useful concept. We are carrying out this for multi-hazard analysis. When we are doing multi-concept, we are applying it to multi-hazard, to multi-technology, to multi-phase analysis, and there are multi-stakeholders of the results or of the user of the same satellite image. So, there are various concepts and various applications where we are applying this multi-concept in remote sensing. So, first is multi-stage in remote sensing. As the name itself is suggesting, stages, there are different stages of the remote sensing data, and here we mean by the platform. When we are talking of the multi-stage, we mean by the different platforms which are used for collecting various kinds of remote sensing images. So, we are collecting this data from ground observation, starting from the ground. We have the ground based equipment, as I have shown you, a radiometer which you can carry to the ground and take the observations, or maybe a GPS device, and balloon data. So, balloon photography was used to take the images, or it could be a drone data. We are flying at a low altitude and drone or unmanned aerial vehicle is collecting the data, or low altitude aircrafts are there, or satellite data from a higher altitude. So, these are the different stages, different platforms from which we are collecting the data, and as you know it now, that these different data sets which are collected at different platforms will give you information at different resolution, at different scales, and also the area covered will be different. So, we will have different scale, different resolution images or remote sensing data product, and the big challenge is now that how to integrate them together, how to use them together at a common platform. So, lower platform, as we know, will cover a very small area at a given time, whereas a higher platform will cover a very large area. So, how the merging of that data sets in order to extract the information has to be done. Now, this selection of the appropriate data, which platform data we have to select, it will depend upon the area which we are going to study and the objectives of the, what are our end objectives. This will determine the selection of the data. Many times we are using combination of several data. So, one single data set from one platform may not be suffice. So, we use the data taken from the different platform, and it will supplement my analysis and give me more and more information. So, this is all shown by multi-stage remote sensing. So, here we have the ground based observations, observation from a certain height from the same ground piece. Then we have the drone based observation, low altitude aircraft, high altitude, and finally the satellite data. So, we are looking at the same area on the ground, but the area covered at any given instant is different from the different platforms. So, these multi stages, these several satellite images, when several satellites are moving at different altitude. So, we have in this particular diagram you can see the Iconos data, which is a very high resolution data. ComSat data is also high resolution. QuickBird, they are moving at different altitudes. Their altitude is not the same and giving us a very high resolution data, because the altitude is low, the resolution is much better now. So, we are many times we are combining the data set from different platforms in order to get the maximum information. Then we have multi-resolution images. So, when we have different sensors in each satellite, or we have different satellites and different sensors, and we collect the data, that data is available to us in a huge quantity, but at different resolution. So, we know the higher resolution data is always better if we want to carry out a very detailed study, or we want to prepare a detailed thematic map, but it will cost us more. So, analysis may also be cumbersome, because we have very large number of scenes actually to analyze that data. So, lower resolution image will cover huge area, but maybe we are not able to see very detailed information. So, we have to actually decide about the resolution, at what resolution we have to work, because not only the cost is involved, but the analysis part is involved. Analyzing a single scene and analyzing 100 scenes, that is time consuming. So, the time factor is there, the cost factor is there when we are selecting a proper spatial resolution. So, higher the spatial resolution, higher will be the cost of the image, and therefore, we have to very carefully select the spatial resolution, so that we are not unnecessary spending the funds for procuring high resolution data. Quantity of the data handling is also not that easy, because you have to georeference the data together when you have in large number, when you want to procure high resolution data and they are in large number. Then georeferencing of the data, creating the mosaic of the data. So, these steps will take time, and you have to maybe improve the radiometric characteristics of the data. So, you cannot straight away jump to the analysis part. So, this all pre-processing will take time when you are dealing with the large number of images. So, as an example, I am showing you multi-resolution images, which is 1 meter resolution image to 0.5 meter resolution image in color, and the thematic mapper in 30 meter, and spot data at 10 meter resolution image. So, the information content certainly is much better at 0.5 meter resolution data. So, it depends upon my application and depends on my purpose, whether I want to get to that level 4 information, or I want only the level 1 information, which is the broad categories present in my area. So, according to that we have to select the data. So, this is another example of multi resolution data. We have at 1 meter resolution data, at 250 meter resolution data. So, you just see pixels. What you see at 250 meter resolution? Just the pixel with the different gray shades. So, there is absolutely no information at 250 meter, there is no information at 30 meter. There is some blurring information available to me at 10 meter resolution, but at 1 meter resolution probably identification of each and every object, each and every feature becomes much easier to us. Then we have multi-band remote sensing images. So, multi-band images are very useful because we know that the spectral reflectance characteristics will change as I change the wavelength. If I am just working in the visible part of the spectrum, maybe I cannot identify many of the features very clearly. The moment I extend my interpretation to the infrared part, or maybe I go to the microwave or the thermal part, I can see much more information from the same area. So, multi-band images are very useful to us in order to derive their spectral reflectance characteristics in different part of the wavelength region. Also, we can create, when we have multi-band remote sensing data, we can create various indices like vegetation indices. So, NDVI, for example, normalized difference vegetation indices, is a very popular indices to carry out the vegetation related study. So, we can actually derive other data sets, we can transform this data set into different data sets when we have multi-band images available. We can create the color composite from these multi-band images, because single image is black and white and we cannot identify, our eye cannot differentiate more than 8 or 10 gray shades, whereas in the color it can go beyond that also. So, some of the images basically single images, black and white images, they will give me similar kind of reflectance for two different objects, but the moment I go for the reflected and the emitted energy and I change the wavelength region, then the distinction becomes much more clear to me. We can develop color composites and we can develop various transformation and indices from these images. As an example, here you can see the individual band, blue band, a green band and the red band. Same area in 3 wavelength region it has been covered. Maybe it looks similar to you, but if you try to focus in a certain area, then the features become much clear to us. If I display the one in blue band, the second image in the green and the third one in the red filter, and try to superimpose the image, the resultant image is the color image. So, when I compare this color image with the individual black and white image, the color image to my eye is much more soothing, and the information content which I can derive from this color image is much more than individually black and white. So, instead of analyzing 3 images, instead of having 3 times analysis from individual image, I just carry out one single time analysis from the multiple band image by having the maximum information. Now, we have multispectral sensors, we have RGB sensors, we have multispectral and we have hyperspectral sensors. So, you will learn about the hyperspectral sensors little later and multispectral sensor also little later, but the thing here is that the same wavelength region is further divided into small compartments. So, visible part of the spectrum is divided into further different wavelength regions. Similarly, the hyperspectral hundreds of wavelength regions, that same region has been divided, and now each wavelength region is used for a specific purpose. It is sensitive to a particular object on the ground. So, once we have the images from the multispectral data, once we have the images from the hyperspectral, several images, hundreds or more than 100 images, then the biggest challenge is that how to select the best bands which can give me the optimum information, how to reject some of the bands. Then we have multi-sensor remote sensing data. So, in multi-sensor remote sensing data nowadays, if we look at the number of satellites, and each satellite may have more than one sensor. So, the number of sensors, the quantity is much higher from those satellites. So, we have lots of data available from those multi-sensors for the same area. If we are talking about the polar satellites, so we can get the same area from multiple sensors data, but at different resolution in different wavelength region of the same area. So this combination basically will help me in identifying the features on the ground, differentiating between the two objects much more clearly. Also, the advantage of multi-sensor is I have data from panchromatic bands, I have data in multispectral wavelength region, I can fuse the data. So data fusion, data merging is another popular technique here, and this data fusion technique have been used for better identification or classification of the satellite image. So here we are taking the spectral characteristics from the multispectral data and spatial characteristics, a better spatial resolution from the panchromatic data. So we are taking the best of the two bands and try to generate a product after data fusion techniques which have the information from both the two sensors together and try to analyze that data. So these data from the multi-sensor is sometimes very useful because we can club them together and derive the optimum information. So this is a flow diagram of data fusion techniques, how from different satellites we have data from the radar satellites, JERS, ERS, Landsat and the Spot. These are the different satellites from the different countries, and we are having now the data sets from these at different resolution and different coverage. So we are what we are doing is we are doing the geocoding. We are georeferencing the data at a single platform so that they have the same coordinate system, and then afterwards we are doing the fusion technique. We are merging the data together. So we are taking best of all the data sets in one single image after fusing. So such kind of images are very useful, not only from the visualization purpose. When you look at the image, that composite image is much better than the individual image, but if you look at the information content, if you try to analyze that image, that also will give you the better results. So this is the data fusion technique which has been used from the multi-sensor. So we have used, for example, the multispectral data and the panchromatic black and white data, and try to fuse the data together using different techniques. These are the data fusion which has been taking place. So spatial resolution is better for panchromatic data, so that characteristics has been taken from the black and white data, and the spectral characteristics, the wavelength region, because the spectral reflectance is different in different wavelength regions. So that characteristics we have taken from multispectral data and try to fuse the data together in order to derive the maximum information content. Then we have the multi-temporal remote sensing images. So there are images from the polar satellites which are temporal in nature. After a certain interval of time we can view the same area, and there are many features now on the ground which are to be monitored regularly after a certain interval of time, and these temporal images are helping us to monitor those areas and to find out what are the changes which have taken place, in which directions the changes is taking place. Very useful when we carry out the flood kind of a related study, so that we can find out which are the vulnerable areas, and we try to identify those critical areas along the river so that we can have some kind of a flood protection measures to be taken at that site. So monitoring the area is very important from several angles, because there is so much change on the landscape. There are some natural changes, there are some man-made changes. So we have to identify those changes from these multi-temporal images, and once we identify those changes, then maybe we can find out the pattern, like growth pattern, a city growth pattern. We can predict when we have the previous temporal images, how the city area is growing, in which direction is growing, at what rate it is growing, then we can extend that particular model and we can do the prediction also. So these temporal images are helping us not only to study the past and the present, but also the future predictions can be carried out with the help of. So, a large number of simulation based study to predict the future scenario has been carried out. So, we have multi-temporal images, for example, in the mining area, how it is helping us. So, the area when it is not mined, you can see the surface line, this is horizontal, the no recovery of the vegetation cover, the area is mined, and after recovery of the vegetation and the mine is fully recovered of the vegetation. So, you can see that what are the changes in the mining areas which are taking place when we have the multi-temporal satellite images. So, this is again another example of multi-temporal satellite image for the flood. So, pre-flood image, and then these are the post flood images of different months, June 27, 2012, June 30th, 2012 and June 29, 2012. So, how much area is affected by this Brahmaputra river which was flowing just pre-flood, you can see that it was confined to a particular area, and now a very large area has been damaged, and how this flood water is spreading in the surrounding regions and creating the havoc and the damage. So, damage kind of a assessment can be carried out. So, whenever some natural disaster takes place, whether it is earthquake or the flood or the fire, forest fire. So, these images, temporal images can be used actually to not only to plan, but also to assess the damage. So, for planning management and for the governance part, these are very useful. Then multi-directional remote sensing data. So, earlier we were collecting the data when the view angle is vertical, but nowadays there is a possibility that we can change the view angle of nadir at a certain degree, and the best example is a spot which has been followed later on by other satellites also. So, we change the view angle. So, multi-directional remote sensing, you are watching a particular area not only vertically down from different angles, multiple scenarios, in order to you can create a 3D model, like you have the stereo images of the same area taken from the two different positions. So, you have multiple angle view. For example, you can have the LiDAR data here and you have the satellite images, they are all looking at the same area. So, you can club this area, you can merge this area, and you can create a very good 3D model of the area because of the parallax which has been introduced in the dataset, and study the area in third dimension. The next one is multidisciplinary, because remote sensing is one area which is a multidisciplinary in nature, where we can use this data for various kinds of applications in different domains, and also this require expertise also from the different domain area. So, here we will talk about the interpretation of the data requires the experts from the different domains. So, if we want to extract, let us say, the geological formations in that area from the same remote sensing data, or another person is more interested into the agricultural domain, or the third person is interested to know the urbanization in that area. So, you require the different experts from the multidiscipline, so that they can apply their knowledge to carry out the analysis of the data and extract very useful information. So, somebody might be useful for a smart city application, the another person could be useful to align a particular road or railway line in that area, or maybe the agriculture. So, this is a multidisciplinary approach is required in order to carry out the analysis, and this slide shows there are different actually ways of data collection and different ways of data analysis. So, this all require the multidisciplinary approach, so that we can use the same data set for various applications. Multi-thematic maps. So, what it shows that if you have the data and particularly digital images. So, there is a very famous proverb about the digital images, like one time right and many times read. That means the same data you can actually use for multiple data creations. So, you can create different thematic maps related to water, vegetation, land use, agriculture, urban area and so on. So, same data sets you can create different thematic layers and then use these thematic layers maybe further integrate into the GIS environment. So, this is called multi-thematic maps generation from the same sets of the satellite data. So, these are the different examples of the multiple thematic maps. This top one is the stream density map, lineament density, slope map, land use and land cover maps, and the contact density maps and the lithology maps. So, different themes have been created, different maps have been created from the same sets of the satellite data using that multidisciplinary approach, and then these could be used in GIS, could be further integrated in GIS for some application. This next is the multi-uses in remote sensing. So, one set of satellite data could be used for different kind of a work. Somebody can use for watershed analysis, another person can use it for vegetation monitoring of the area, the third expert can use it for the global change analysis. So, same data sets is being used for multiple applications, highway engineer use for the other application sets. So, this is all the multi uses, the same data sets can be used for different application, and this slide shows that we have the satellite data, and on the periphery there are very large number of uses applications, whether it is for resource exploration or incident mapping, or it could be the site selection analysis or engineering design. So, there are very large number of uses of the same satellite data. So, in a nutshell, there are some advantages and there are some disadvantages when we are using the data from different platforms. So, whether it is a ground or UAV or aircraft or the satellite data, there are advantages and there are disadvantages because of the cost involved, because of the resolution, because of the area which is covered. So, we have to make a compromise between the three and also remember what are the end products objective when we are selecting a particular satellite data. So, the utility of the multi-concept which we have learned in this lecture is that you have very large number of satellite images, very large number of data products which is available to you today in the commercial market, and what you have to do is for a particular application you have to select the optimum data sets so that you can derive the best results, you can derive the most accurate results in the given time frame. That is also very important, that within the given time frame we are able to derive the results. So, this is very important to understand the multi-concept so that we select the right kind of satellite image for our application. So, this is all about this lecture. Thank you.